Let's resume with the polynomial functions. So if we take a look at that graph that you guys have in number 4, there's a root or an x-intercept at -2, +1, and 4. So remember that we can build those in the binomials that belong to them. Right, these are roots or x-intercepts, so they're supposed to make the function 0, so they actually make each individual parentheses or binomial 0. Check that out. You plug those in, they make the equation 0, right? So we could start off with this as a blueprint and then see if it has the correct y-intercept of 0, -8. And it does not, and I can tell you that simply for the fact that 2 times -1 times -4 is +8, not -8. So that's bad news because it's not right, but it's good news because we know all we need to do is to flip it. Or, I said flip it, what I really meant was flip over the x-axis, but to do that, we can simply negate the entire function. So what we get from there is going to be a standard form. Remember, our trick for standard form was to pick 2 and multiply. So I'm going to bring these 2 down. I'm going to go ahead and find the product of those. Right? You can use the box method for it, whatever you got to do. And then from there, another distribution party. So that kind is going to be our x to the third. Our -5x squared plus 4x plus 2x squared minus 10x plus 8, right? And there's that plus 8 I spoke about, right? Now I'm kind of feeling pretty good about myself. And then all we've got to do is say, okay, this guy's going to visit everybody. So I have -x to the third plus 5. Well, oops, I got the plus 5x, or so minus 5x squared, which becomes positive. But first, let's think, what would that be combined? So -5 plus 2, that would have been -3, right? So -3 is going to convert to that +3 because of that negative. So -3x squared converting to the positive. Okay, so +3x squared. The 4x minus the 10x would have been a -6x. This negative is going to make it a +6x. And then the -8 is going to become, the +8 is going to become -8. So that would be the standard form. Go ahead and check it. It's 3 degrees. So it crosses 3 times. It's got the correct y-intercept. Feel pretty good about that one. Number 5. It's a complex expression. Right? And our instructions were to simplify. How are we supposed to simplify? Well, we're not supposed to leave a radical in the bottom. So if you look at the original, it has the square root of 3 in the bottom. We're going to use something called the conjugate. It doesn't have anything to do with the language that I'm speaking in, but I am going to have to multiply by that chameleon or that fancy 1 to allow that conjugate to cancel itself out. Remember, it's exactly the same term with a different sign, right? And the beauty of it is that we can FOIL, right, but the plus square root 3 and the minus square root 3 is going to cancel out. It's going to get rid of all the radical terms. And then here I've just got to distribute. So 2 minus 2 square root of 3. I'll take that just a little bit further because square root of 3 squared is really just 3. And 1 minus 3 is really -2. So I have 2 subtract 2 square root of 3. A little bit further. Some of you want to stop here, but look. There's all these coefficients of 2's. We can reduce those and make this -1 plus the square root of 3. 2 over 2 reduced to the -1 is 2 over 2 reduced to the +1. So you can write the 1 there if you want. You don't need it. Because if you have 1 of something, you don't say, I have 1 dog. I simply say, I have a dog. You wouldn't say that about a cat. You know, who'd want a cat? Anyway, number 6 might seem like a curveball, but I wanted to throw one in there and say find the solution to the system. The system is multiple functions, the solution to which would be where the functions intersect or have common points. So we're simply looking for where f of x equals g of x. So if f of x was the x squared minus 9, g of x is the x minus 3, I'll go ahead and pull this up for later. Then we're simply looking at where do they cross? Where are they the same? How do I figure that out? So, it's a quadratic equation. How do we solve those? We set it equals 0, so I've got to move everything. Plus x minus 3. So I've got x squared plus x minus 12. That's going to give me two answers, I think. Right? Did I do that correctly? No, it's minus x, sorry. Minus x. So I've got x minus 4, I've got x plus 3. That's going to give me answers of x equals 4 and x equals negative 3. You see, though, I was asking you for points. Points require an x and y value. So we're going to plug in 4 and get a number. We're going to plug in negative 3 and get a number. We plug in 4, and the great thing is we can plug it into either one as a system. It's on both lines. I'm going to choose the linear one because that's cake. But if you plug in 4 here, 4 minus 3 is 1. That's a point for 1. If I plug in negative 3 here, negative 3 minus 3, that's negative 6. Let's see, are those on the same? Did I do something wrong?